will start first with why today everybody is small background, as I understand it, talking about digitalization, AI, ML, deep learning, etc. So today, with the existing extensive use of your computers and software-based technologies, each business as such has and generates lots of digital information. The renewable assets with thousands of solar modules, hundreds of inverters, multiple wind turbines in a single wind farm, and then there is a weather-related data. It generates a huge amount of data, a huge amount of information. This information is as such is already digitalized by means of SCADA. So Julian has rightly explained there is a difference between digitization and digitalization. So the information is already digitized for the renewable assets. But now this information is still in a siloed information, right? It's available at plant level. If my site person has to take some decisions, he still needs to process that information or interpret that information before he takes some decisions on it. So to get the ready-to-use analysis, right, which is useful for taking the decisions on the performance insights, this information further needs to be integrated, processed, correlated, and analyzed for insights in terms of their impact on each other, because all these parameters, right, at plant level and weather parameters, they are interdependent on each other, and then collectively they impact my overall performance of the plant. So the digitalization is not just a single technology. It's integration of all these technologies, systems, your processes, your manual processes, and I will say it should be throughout the entire value chain of your renewable ecosystem. So now we are all aware that unlike conventional energy forms of energy, where the resources, right, the availability of these resources is known, and to great extent these are predictable. The renewable energy, on the other hand, is dependent on the resources which are highly unpredictable. So it is all the more and very important to ensure that my assets uptime is maximum, is maintained at maximum. My assets are operating at highly efficient level, so that for any given level of resource, my assets are able to maximize the output and there is no opportunity loss. Now to do this, to achieve this, I need to have those insights into my asset performance, and for which I need to integrate all this humongous amount of data at one place, so that I can derive those insights from this data. Having said that, there are well-known advantages of digitalization. The transformation, that is the digital transformation from classical way of working to a data-driven way of working, is not always easy. Classically, most of us are tuned to take decisions based on our knowledge, based on our past experience. And this usually happens when further information insights are not readily available or need some efforts to derive those insights. Another challenge, I will say, in the digitalization is the way the organizations are cultured. In almost all organizations today, if we see, the data is a lot of data is generated among the functions, departments, but very little is shared other than the end user of data with the other departments. So as an organization, I'm not taking the advantage of this siloed business intelligence, right? So to digitalization, what is required is to integrate all this information at one place. So the management or the organization can take those informed decisions, data-driven decisions. So with the information in the entire value chain is digitized and digitalized, the manual processes are integrated with them, the entire value chain of, say, a renewable cluster gets benefited, right from planning, engineering, procurement, quality, O&M, vendor performance management, inventory management, and so on. So now I will come to your question of some technical jargon of digitalization. So frankly, I am not an IT expert. So Julian, you can pitch in if I am going wrong somewhere. So I will try to explain this in a simplest manner the way I understood it. First come to the Internet of Things. So this is basically a system, network, which is connected system wherein per se site level equipments, sensors, softwares, applications are connected over the internet. Okay, and then this information is available to me at a digital platform or any digital platform for further analysis of that. So the IoT is also called as IIoT for industrial. So IIoT is basically industrial Internet of Things, very useful for industry. So this typical IoT device in day-to-day use are your smart cars, smart lights, smart refrigerators. We can call them as the IoTs, which can be connected on your Wi-Fi, which can be connected on your internet, and then you can operate them from remotely. You can monitor them from remotely. The well-known applications of AI in day-to-day usage are your smartphones, smartwatches, connected cars. By being IoT, they can transfer the data to the OEM manufacturers. We can further diagnose your cars and all. When it comes to renewables, it is individual assets to various sensors and systems like SCADA. When connected over the internet, we refer to as IoT. This information, when available through IoT, can then be used for various analysis by using AI, artificial intelligence, and ML tools to derive useful and data-driven actions, including various predictive analytics. So that is, as per me, the IoT trillion you can add to it. Now comes the artificial intelligence. So artificial intelligence is the main branch of prediction-based technologies, which churns out a lot of data and come out with the insights from that data based on the pattern and behavior of that data. It includes domains like your machine language, machine learning, neural networks. In the simplest forms, the AI, the artificial intelligence, refers to the systems or machines which can mimic the human intelligence to perform the task and can improve themselves. Like machines can always, or most of the times, do it better than the human beings and repeatedly the same level of performance. So when it comes to intelligence, so how do the human beings become intelligent? Right? So from our childhood, we learn things by observation, by our experience of good and bad results of our actions, and also from our educational learnings. This process of gaining the intelligence to carry out certain tasks by taking decisions is artificially developed into the machines and systems to either take decisions themselves or help us to take those decisions based on the analysis of huge amount of data based on their intelligence, which is gained over a period of time by mapping the historical data, by mapping the patterns from those historical data. So these machines get that intelligence, and then they either take some decisions themselves, action themselves, or they can support our decisions. So in short, AI system processes a large amount of data much faster and obviously make predictions more accurately than humanly possible. Not impractical, but humanly possible. So examples of AI ML maybe in day-to-day life is your speech recognition. Good examples are Alexa and Google Home. Image recognition, which is your face unlocking on mobile, Facebook photo tagging, traffic alert, chatbots, and so on. So at Tata Power, we are making use of all these technologies. So we have integrated all our sites through IoT at our digital platform in Mumbai, which we call it as a CCRA, Common Control Room for Renewable Assets. And then we are utilizing this data other than a basic usage of real-time monitoring and descriptive analytics for more advanced analytics in terms of intraday, day-ahead generation forecasting, predictive and prescriptive analytics for inverters, for our ACBs, for our wind turbines, as well as maintenance planning of our RESs. So, Vinay, the next steps for us, we already have our in-house platform. We call it the CCR. It's a common control room for renewable assets. It already has around 70 sites, solar sites, and 22 wind sites connected. Now, as Julian said, it's a huge data, right? It's already there. We are already into the real-time monitoring, the descriptive analytics. The next stage would be in terms of analytics, would be to go for the predictive analytics. So we are into inverter anomaly prediction, working on that, wherein my system or my platform will tell my O&M teams when it is likely to fail, right? So that they can take those corrective actions proactively and save that much of downtime. Similarly, on the module cleaning, which is again a critical part of the solar plant, right? So it can recommend the site teams based on the AI, ML, and the historical data and as well as the weather prediction, which is the intraday or the short-term prediction. It can tell my O&M team when to take your module in evenings. For example, suppose tomorrow there is a prediction of very good sun out there, so I will tell the system will tell my team, go and clean more modules, incur more cost in cleaning, but it will benefit you tomorrow because it's going to be a sunny day tomorrow. So such types of insights we are planning to give it to our site teams. On the design front, the content front, see, earlier we had a CCRE version, that the platform, the user interface was such that the user has to go to the multiple pages, right, to get those insights. So today we are developing a user-specific dashboard. So when he logged into the system, he gets all the information required for him to take those decisions, what he is going to do today, which inverters he is going to look into because of their lower performance. What is my generation now and what it is going to be in the next remaining period of the day. All this information would be available to us in one place. He did not go anywhere else other than to do a further deep dive into it. Then the systems also has the basic functionalities like real-time monitoring, then the inverter analytics of start and stop. So the next step for us would be to go for predictive analytics, making this platform the common platform, as Amit was also saying and you were asking. So everything is available at one place. So earlier, for example, the reviews were used to happen outside, right? And during the review, there used to be some requirement of how this particular inverter is doing, why this inverter, how many times this inverter has tripped, whether this inverter is repeatedly tripping. Now to do this, I have to go again to my digital platform and see those trend analysis. We are trying to combine this now. So bring in that review management platform also on CCRE. So wherein my business head can review the performance of the plants from there and there itself. And to click a button, they can go into the further analytics. The other advantage of bringing everything on the same platform is the data quality. The moment you have different platforms and different data entered in the different systems, there is a challenge in having the same data at everywhere. So that is another advantage if we bring everything at one place.